Okay, so far, everything that we've done with the robot, all the motions, all the rotations, all the translations, everything was referring to this one particular point that is here at the center of the flange, and it's called the TCP, the tool center point. So when we moved, or when we set X, Y, Z, it was for this one point here, or when we rotated around a vector, it was a rotation around with the center at this point here, all right? But that's very unlikely the point that you will be interested in using, because if you're using an industrial robot arm, then you probably have like some kind of tool attached here, and then the point that is important for you is not the center of this, but it's somewhere here or here or here, depending on the characteristics of your tool, right? So it will be that point that it's important for you and that you want to use for motions, for rotations, etc. So imagine, for example, here, imagine that this was like a Sharpie that I was drawing with, or that it was like a heat gun that I want to deposit gun with, or like a welder, right? So it's this tip here that I'm interested in. For this particular attachment that I made, I know that this distance is exactly 100 millimeters away from this point. So that would be like the length of my Sharpie or the heat gun, whatever. So there's two things I could do. I could just write my program, and if the surface that I want to deposit glue on is like at 50 millimeters from the ground, then I can just offset all the coordinates of the motion, like an extra 100 millimeters on top of the surface, and that's how I can work in my program. But that's not clean, that's not nice, we may forget about that offset, and also, that's only going to work for very simple Cartesian motion. If we rotate, then the rotation will be always based on the center of the flange, right? So that's why when we work with robots, and the same thing in Machina, what we can do is we can define a tool that is going to be attached to the robot, and that tool is going to incorporate the offset of this center point in X, Y, Z, whatever, and if we want also an offset, a change in the orientation of the axis that define that TCP, that tool center point. For example, for a Sharpie, it's going to be something very simple. I just want to move this coordinate system 100 millimeters this way, right? So if this was the previous coordinate system on the flange, what I want to do is I want to move this coordinate system 100 millimeters in the set direction of, so if this was here, I want to move it 100 millimeters in the set direction of what I had before, right? And perhaps I want to rotate it if I want to do more complex things, well, but that's up to you, all right? So the simplest tool that I can define is one where I am moving the TCP an set offset from the base of the flange, right? So how can we do that? In Machina, I'm going to go to the console. I have an action that is called defining a tool, right? So I can define a tool, open parentheses, and the first thing that I input is the name of the tool. So for example, heat gun. I'm going to, and it's a string, so I need to use double quotes, all right? Then the next thing that I need to do is, in the coordinate system of the previous tool, of the flange, I need to specify where the new center is. So remember, if this was like this, right? If this is the coordinate system of the flange, I'm going to move my coordinate system a bit down. If it was here, I'm going to move it 100 millimeters. So the offset is 100 millimeters in the positive z direction. All right? Like this. From here, I want to move it like this. All right? So I'm going to specify that by saying I'm going to move the center of my TCP 0, 0, and 100 millimeters positive in the coordinate system of the flange. All right? Then I'm going to specify the direction of the x and y vector, right? So if I just want to move this up a little bit, like this, then you can see that this x is parallel to the previous x, and this y is parallel to the previous y. If I was rotating this coordinate system, it would be different. But since this x is the same as this one, and this y is going to be the same as the previous one, then there's no change in rotations. So what I'm going to do is I'm going to say the x vector of the new TCP is the same as the previous one, 1, 0, 0. And the y vector of the new TCP is the same as the previous one as well. So 0, 1, 0. Then I need to specify the weight in kilograms. So something like 0.1, 100 grams. And then the coordinates of the center of gravity of the tool. That's going to be roughly somewhere at the center. So 0, 0, and 50. I close parenthesis, semicolon, and then I hit enter. And then right now, Machina now knows that I have defined this tool. And what I can do is I can say, let's attach virtually that tool that I have defined before that is called hit gun. All right, and I use double quotes because it's a name. I hit enter, and I see that I just forgot that I changed the name of that. So now it's called Attach Tool. All right, so I just did that, and right now it's working with this TCP as if it was like this. So look at what's going to happen. If I rotate around the y vector now, rotate around 0, 1, 0, minus 90 degrees. Instead of rotating like this, it's going to rotate around this point here. All right? So you see how this point is maintaining position? All right? And if I say move to coordinates 600, minus 200, and 500, those coordinates are the coordinates. Now the motion, this point here, the offset, is going to be, this point is now at 500 minus 200, 400, not the center of the flange. I can rotate back up by doing the same, but with positive, and you can see that this point now. So if I was milling, if I was applying gun on a surface, applying glue to a surface, I don't know. Now it works much better. All right. If I was drawing on a vase, something like that. That's how you define tools. I can say detach tool. I open and close parentheses, no data needed here. And if I do that, now you can see that now the robot thinks that there's nothing on the tool. And if I rotate again, you can see that now it's rotating back at the center of the flange, not anymore on this tip that I defined before. All right? So that's tool definition. All right? Tool definition is very important because we usually have tools defined here. We usually have tools attached to the robot. All right?